Hello and welcome to my channel Automotive Curiosity. In this series of electric vehicles, in earlier video we talked about the high voltage battery pack exploded view, high voltage battery pack overview, and today in this video we will be talking about the battery pack circuit layout. Before moving ahead further in this video, let me introduce myself. I am Krishna and I am a mechanical engineer by profession, and I have more than 11 plus years of experience of working in various automobile companies like Tata Motors and V Commercial Vehicles. And currently, I'm working at Mahindra and Mahindra Limited as project manager for electric vehicles. One standard term should be remembered while talking about the electric vehicles battery pack, which is cell module. So what is a cell module? Cell module is nothing but a set of cells which are connected in parallel to each other. Here we can see these are the sets of cells. Each bar represents one cell. So 1, 2 and 3. This is making one set which is called module, and this is the another set of cells which is second module. So if we start counting, all this number will go up to 24, and as we notice, each of these cells, three cells are connected in parallel. So we say the battery cell configuration of Tata Tigor EV is 3P24S, where P represents for parallel connection and S represents for series connection. So there are the sets of three cells, and each cell inside these sets are connected in parallel, and all these sets or the modules are connected to each other in series with help of bus bars. We will understand about the bus bars ahead in this video. So this is the battery pack circuit layout of Tata Tigor EV. On the left hand, here is the real image of Tata Tigor EV battery pack layout, where its top cover has been removed and the critical components like contactor, BMS, low voltage cable, cells, bus bars are easily visible. On the right hand, all these components which we can see here has been shown by using the pictorial representation to ease the process of explanation. Here we can see the components: contactor, high voltage cable, low voltage cable, current sensors, BMS, thermistor expansion module, pre-charge kit, and the modules and bus bars. So as explained earlier, three-cell configuration of Tata Tigor EV is 3P24S. 3P means there is a set of three cells, 1 2 3 1 2 3, and all these three cells are connected in parallel, and all these modules or these sets of yellow and blue cells, which is around 24 in numbers, are connected in series to each other through the bus bars. Now one may ask, what are the bus bars? So bus bars are solid metal bars used to carry current. Typically the bus bars are made from copper or aluminum. Bus bars are rigid and flat, wider than the cables but up to 70% shorter in height. They can also carry more current than cables with the same cross-sectional area. Here is the image of bus bar used in Tata Tigor EV. Now we'll move ahead to another critical component of electric vehicle battery pack, which is contactor. So contactor is a device that is used for making and breaking the electrical power circuit. In our case, contactor is used to connect the EV battery pack to DC charging source and for communication between the charger to BMS. Here we can see there is contactor which has been placed between this complete circuit and the power of DC supply. This, as explained, this connector is used to connect the EV battery pack to DC charging, and for the communication, this is the mode of communication, this low voltage wire which is coming from BMS. And for, so we say the contactor is also used for the communication between the BMS and the another connected circuits. Connectors has the capability of protecting the critical components from electrical power surges. These surges can destroy, can give the lifelong damages to electrical components. Let's understand the working of contactor with help of this simple diagram. So here we can see these are the terminals L1, L2, L3 which receives the power from three-phase power supply, and these are the outgoing terminals which are supplying power to that motor. We can also see there is a low voltage wire which is coming from this DC power source and going inside this contactor. We will try to understand working of contactor with help of some animation ahead in this video. So every contactor has a coil. Here's the coil which can be excited through the help of low voltage power supply. So this is the source, power source supply, which is giving the DC current for the excitation of this coil. As this coil gets excitation from the low voltage power source, it creates a magnetic field, or we can see a electromagnetic field. As a result of that electromagnetic field, these contacts moves in that direction to make contact and complete the connection or the circuit. Let us see the working of contactor through the help of animation. Another critical components of electric vehicle battery pack is BMS, or the battery management system. A battery management system is an intelligent component of a battery pack responsible for advanced monitoring and management. It is the brain behind the battery and plays a critical role in its level of safety, performance, charge rates, and the longevity. BMS monitors the aging and charging status as well as the depth of discharge of the battery cell modules. It controls the charging cycles smartly and optimizes in regard to speed. Thermal management or overcharging is another special feature of the battery management system. How does the BMS controls the overcharging? So BMS calculates the SOC. What is SOC? SOC is the state of charge, which is nothing but the amount of energy remaining inside the battery. BMS also keeps track how much energy goes inside the battery pack and goes outside the battery pack. It also keeps track of the cell voltages. Let's understand the SOP in a little bit detail. Charge SOC. In a simple words, the state of charge is your fuel gauge for battery operated vehicles or e-vehicles. It is the real time or the actual capacity of the battery compared to its full capacity. Just like your cell phone battery, it is measured in terms of percentage. Example, 100% SOC means battery is fully charged to its capacity, and 0% SOC means it is fully discharged. Now the next component is the thermistor sensor module. Thermistor sensor module is used to sense the temperature and convert it into output signals. It is associated with the both analog output pin and digital output pin labeled as AO and DO respectively on the board. Thermistor sensor module is made of semiconductor materials. High voltage cables are the another critical component of electric vehicle. Cables running internally through the vehicles can be divided into two voltage categories. First is low voltage category, which means between 0 and 60 volt, and the high voltage category, which means anything above 60 volts, typically running up to 600, 800 or 1500 in the e-mobility sector. To address the safety concern, or the car companies have developed certain indicators that can help workers to identify the high voltage cables in vehicle. Color coding: orange, which mostly used as a representation of high voltage power supply, and nowadays blue color cables is also represent to identify high voltage lines in electric vehicle. Pre-charge kit. The pre-charge feature eliminates its initial inrush of current and eliminates the nasty spark. How does the pre-charge feature work? The pre-charge feature adds a resistor and another smaller contactor across the main power contactor inside the BMS. Thank you so much for watching this video. I appreciate your patience for staying with us till end of this video. Hope you may have liked this video. Please like, subscribe and leave comment below in case if you have any question or any feedback. We will see you in next video.